Hey, welcome to Sketching Straight Lines. Do you remember some of this stuff? Here's a very, very important question right in the centre. And why is this question in the centre? It's a central question. Yeah, central to all that we're going to do now in trying to draw a straight line. What makes this line straight, and why is it in red? Why is it in red? Because it's also a hot question to answer now, to work out where to put our line on the Cartesian plane or the Cartesian coordinate system. We've got a line up here, come up here, that's got a negative slope, hasn't it? And this one's got a positive slope. Do you remember that? We talk about coming along the x-axis. As x increases, what is y doing? Does y increase or decrease? So if we look at this one here, as we go along the x-axis, the function is increasing. It's going to have a positive y step over x step, isn't it? Remember this. So x is going to be positive down here. If it's going up, y will be positive, and the y step over the x step, which is the slope or gradient, will be positive. Do you get it? What about over here? Come back over here. As x increases this way, what's happening? Y is going down, isn't it? Okay, so the y step over the x step, y is going down. Y is becoming more negative. It's decreasing. So the y step will be a negative divided by a positive. You always come up here, think about x increasing, moving to the right, and looking at what the line is doing, what y is doing. So, do you remember? Well, what about these down here? These are a little bit easier, these two down the bottom, because this one is what we call a horizontal line, and it's got a very simple rule, y equals 5, which means it can't go anywhere. All the y's have to be 5 and they can't change. So going to keep going and to the other side there as well. That's an easy one. And what about a vertical line? This one over here now. What about a vertical line? Hey, that's the y-axis, mate. Got the wrong line there. How about this one here? Okay, so that's a vertical line. X is -2. Why? Because, hey, nothing to do with y, mate. X is always -2. You keep going up and down. You don't go anywhere in the x direction. So x is always -2. So they have special equations, those two lines. But the burning question is, what is the easiest way to graph all these lines? I guess it's pretty easy to do these two. But what about these up here? And let's do it now, and to do it, I think we've got to find out, or remember, what makes a line straight. That is our central question. Hey, why? It's in the centre, mate. Okay, come down and let's have a look. Sketching linear graphs. This is from Pearson's textbook, and you should have a copy quite handy by there so you can check it out along with these podcasts. So here we go. The equation of a linear graph can be written in the form y equals mx plus b. We usually use c, but it doesn't matter where the number in front of x is the slope or the gradient. Pearson's are calling it the gradient. And then this is the number where it crosses the y-axis. Okay, y-axis intercept, or just the y-intercept. So do you remember? Well, I'm going to remind you, because come on down now and have a look at this little grid. Okay, so we've got a grid here. What makes a line straight? Remember, that's our burning question. So let's take a line. What sort of line would you like? I reckon we'll take the line 2x plus 1. That seems a friendly dude there. Remember what we said, that this is the y-intercept. So let's start there. On the y-axis. Can you see that? That is the point 0, 1. On the y-axis we've had no x movement. It's just 0 and up 1. And then this is the slope or gradient. Hey, do you remember? That's what makes a line straight, doesn't it? Yeah. As you go across 1 in the x down here, you go up 2 in the y, because this is a y step over the x step. And if it is, it means y is 2 for every 1 in x. Let's do it again. we're over here. Let's go 1 in the y in the x and 2 in the y. Hey, I think this little dude is the answer to the question, what makes a line straight? It's because it's got a constant gradient. Want to do more? Come over here. We'll go 1 in the x and 2 in the y. Hey, that's what keeps it straight, mate. That's what keeps it straight. And back here, you could say, what was it before? Where would we be? 1 in the x and 2 in the y, it would be back here somewhere and going that way. So we could go backwards as well, as long as we watched what we were doing there. Okay, so what makes a line straight? It's a constant slope or gradient. Constant slope or gradient. The y step over the x step. So you don't pull the line off of straight. Do you get it? Okay. Want to do another one? Of course you do. This is great fun. So let's use y equals, what can we have? Let's say neg 3x. Hey, what's that going to do? And plus 4 maybe. Okay. So where would we start? Well, not a bad way to start is on the y-axis with y is 4. So it goes through there. Now this time, every time you go, 1 in the x, what's happening here? Hey, this is the slope. This is the y step over the x step. And so what is it? It's neg 3 over 1. And we usually keep the x positive. Do you remember from just a few minutes ago, we move 1 in the x. We always move positive in the x and look at the response. 1 in the x gets a response of neg 3 in the y. Let's do it. Let's start here. Go across 1 in the x. And now we've got to go down 3 in the y. Down to there. 1 in the x and neg 3 in the y. 1 in the x, neg 3 in the y. Hey, that's what makes the line straight, this constant gradient. Okay, and this time it's positive x. Always think about moving positively in x land, and then look at the response in y, and it's going down, mate, by 3 every time. And so this line is going to slope like this one here, left to right, if you like, downwards there. You need to think of this as x, as you move along the x-axis to the right, what's happening to the line? It's going up or down. Do you get it? Well, let's have a look at some examples now based on the answer to the question, what makes a line straight? And you start at the y-intercept and then you build the line with its constant slope, because that's what makes a line straight, mate. Okay, let's come down and have a look. Here's worked example 7 from Pearson's, and we're going to work with this up here. Are you up there with me? Y equals 4x plus 1. And first of all, what are we going to do? Y equals 4x1 has a y-intercept of 0, 1, that number there, and we're going to look at that in a bit more detail in a minute. So you start there on the y-axis, come on down here, and you plot that 1 there, and then you say, well, what is the slope or the gradient? It's 4. I don't like rise and run. I think you're old enough to do it properly, and the slope is y step over x step. Actually, better mathematics than that would be delta y on delta x. If you remember, in mathematics we use that delta sign, that Greek capital, to mean changing. So, what are we saying here? If the slope is 4 over 1, okay, in this case, move 1 in the x. Well, let's do it. Come over here, and we will move from our y-intercept 1 in the x, excuse me, and we have to go up 4 in the y. Don't like their scale much, because they've used a big scale here and a smaller one up there, but don't worry. It still works, mate. Excuse me. Okay, so what do? Here are the steps over here. Work out the y-intercept and the slope. Start on the y-axis and then move across 1 and then up the y-step. Okay, and then you join the 2 points up. How many points do you need to plot a straight line? Well, only 2, because there's no curvy bits. Okay, do you get it? That's one type. Let's see if we can do the same thing when the equation looks a bit different. You might realise over here, come up the top here, sometimes the equation is not in the form y equals mx plus c or plus b, whatever. And so what can you do with that? Well, here it is. We need to do a little bit of our algebra. Remember that stuff now. Trying to get y equals. Excuse me. Trying to get y equals here. So there's y. Excuse me. It's been multiplied by 2. And then 3x has been added. Let's reverse the steps down. Let's subtract 3x. There it is. So 2y equals 4 take 3x, or neg 3x plus 4. And then dividing by 2. There we have it. So we have put this line in a new form. And this is one of the reasons we do algebra. And this isn't a bad little tool here. Work out what's been done to y and then reverse the steps. Unpack your present, if you like, and go back to the beginning. What can we say? Well, there we can say the y-intercept is 2. It's now by itself in mx plus c form. Okay, so when you get it in this form, we have immediate access to the y-intercept and the slope. So we'll go there, we'll plot that point, and then the gradient or slope is neg 3 over 2. So let's have a look at that. That's the y step over the x step. And that is, well, neg 3, you'll usually put, excuse me, you usually put the x step as positive. Okay, you think about moving positively along the x-axis and look at the response of y. So let's do that here. Starting at our point, moving 2, and we've got to drop down 3 because the y movement is in the negative direction, negative 3. Oh, excuse me. Okay, so then rule a line through the 2 points. Do you get it? Okay, you might have to pause the presentation and go back and check it out. Are you ready to try some problems? Let's do it now. Okay, so here are some problems, and I think you need to actually do all of these to check it out. Now, here, this is the first one. I've split Pearson's up. Pearson's do all their worked examples and then all the questions on them. I've taken them in little pieces so that you can focus on one aspect at a time and then build. I think that's better. Anyway, these are okay here. These here need rearrangement into the form y equals mx plus c. Now this is very useful also when you're using technology, because all technology, when you're graphing with technology, requires an input of y1 equals, excuse me, y1 equals. So this would be in a good form. These are already for entry into a calculator or other forms of technology. These need to be rearranged. So this is an important skill. I want you to spend some time on question 2, rearranging it and making sure you understand what's going on there. All right, so pause the presentation, have a go. I'm going to go on because down below here, come on down with me now, the answers. So here they are. I'll bring them all up so you can see all of them. So that's what you should end up with your graphs. So check them carefully. In this batch here in question 2, check that you got the right rearrangement. They put the formula for the line as it was. They haven't put the mx plus c form. So you'll have to check that by this, because what would this be? It means y would have been 1x take a third. Excuse me. Take a third. Because, oops, no, put it around the wrong way. Here, neg a third is the slope, and the y-intercept, their b value, is 1. So did you get that rearranged form? So each of these you might write down and check whether that's where you might have gone wrong. Write down what rearranged form they got and check it out. Okay, so toggle back, do those examples and check your work as you go, almost one by one, so you're reinforcing the right method. Don't keep doing them and find out then they were all wrong. Check them as you go and pick up and maybe ask somebody else or a teacher to help you if they're not working out. Okay, want to do more? Let's go on now and have a look down here. What if you get sick of rearranging, here you are, get sick of rearranging that. What about just trying to graph it as it stands? Not make it y equals mx plus c. We're not going to use that this time. Okay, just let's work with it as it stands. Neg 3x plus 2y equals 6. It's called the general form of the equation of the line, as you might remember from before, whereas this is called the slope-intercept form, because obviously the slope of the line and the y-intercept are clear in those positions. So this is the general form, and can we easily plot the straight line from the general form? Well, what we're going to do is focus on finding the x and y-intercepts. Okay, now let's have a look at what that is. They've said here the x-intercept is neg 2 naught and the y-intercept is naught 3. And they've put down how they've done it. The y value is 0 at the x-intercept and the x value is 0 at the y-intercept. Yuckity yuck, what's that? Okay, so knowing this helps to calculate the intercept values. That's what they're saying here. Right, let's unpack that a little bit. Let's have a look at this line in a bit more detail. So come on down here. Neg 3x plus 2y equals 6 is what they were playing with there. So I've put in simpler terms, or I've plucked out from Pearson's in simpler terms, the statement they made, and let's unpack it. To find the x-intercept, substitute y equals 0 in the equation. Now that sounds like an algorithm, a basic rule, but do we understand it? That's important to understand what you're doing. So we're trying to find where it cuts the x-axis, so that's this line here. And we put y as 0 in the equation. Why do we do that? All right, well, on the x-axis, let's start it here. This is called the origin of measurement. In this direction we're measuring x's, positively and negatively, and this direction we're moving in the y direction, positively and negatively. Now, on the x-axis, what have we done? Hey, we haven't done any movement up and down, have we? We haven't gone anywhere. So the x-axis has actually an equation, y equals 0, because in y-land we've moved nowhere. Let's have a look about the y-axis. So we start off at the origin of measurement, origin of movement here, and on the y-axis we could move up or down. Have we moved anywhere in x-land? No. We haven't moved to the left or right. On the y-axis we've just moved up and down. So the y-axis up here is called the line x is equal to 0, because there's been zero movement backwards and forwards in the x direction. All right, so these are the things, this is the reason why these two here, we're going to put x is equal to 0 and y is equal to 0 in our equation. So let's come over here now. What will we do? Let's find the x-intercept. All on the x-axis, y is 0, for the reason I just said. So let's stick y is 0 in the equation. You get neg 3x plus 2 times 0 equals 6. 2 times 0 is 0. So we've got neg 3x equals 6, or x equals 6 divided by neg 3, which is neg 2. Let's go to the axes here and plot that. There it is down there. X is neg 2. Let's now do the y-intercept. All on the y-axis, x is 0. Let's go to the equation. Neg 3 times 0 plus 2y equals 6. Neg 3 times 0 is 0. So y equals 6 divided by 2 is 3. Uh-oh, I've stuffed that up. Wrong axes, mate. that should have been x is -2, should have been over here, and y equals 3 is up there, making some mistakes here. Okay, so let's just check that out now. The x-intercept is -2, there it is there. The y-intercept was 3, there it is there. What's our line now? We'll just join those up. Okay, so that's another way of creating our 2 points. We only need 2 points because the thing's straight, mate. No curves. So pretty easy to map out. And that's an easy way too. There's another way of drawing the graph of a straight line. All right, come down and let's look at some more examples from Pearson's now. So here's an equation, 2x plus 3y equals 12. We've just had a look at why we would put y as 0 to get the x-intercept. And when you do that, 2x plus 3 times 0 is 12. 2x is 12, so x is 6. And therefore the x-intercept, remember on the x-axis, y is always 0. Here it is here. You haven't gone up or down on the x-axis, so y is 0. On the y-axis, x is 0. So in place of x in the equation, you put 0. 3y equals 12, y is 4. So the y-intercept is always x is 0 and y is 4. So let's plot those now. X-intercept was at 6. Y-intercept was at 4. So joining them up, we have a graph of that straight line. So that's a pretty quick way also of drawing the graph of a straight line. Let's come down and have a look at one more example here. What about the graph of y equals 3x? Hey, that's interesting because here we have a slope of 3 and no y-intercept. So what does that mean? Well, no y-intercept, not exactly true. We don't have a number on the end, so we'd say, hey, it must go through 0. Okay, so if there's no number on the end, it means the y-intercept is at 0, 0. So we go back to the other method, excuse me, and say, right, the slope is the y-step over the x-step, which is 3 over 1. So we go to 0, 0 down here, we go across 1 and up 3. So that's a special case of those lines that go right through the origin here, and so they don't have any number on the end, so the origin is 0, so that's the y-intercept is at 0. Do you get it? Want to practice? Come on down and have a look at some of these now. Here's question 3 and 4 from Pearson's. I've split them up so that you're biting off little pieces at a time and just building your skills. Don't want to suffer from mathematical indigestion, mate. Don't gobble too much up at once. Let's consolidate as we go along. Okay, so here they are. This time we won't rearrange. We'll use the x-intercept is when y is 0. That implies the x-intercept, and when x is 0, that will lead us to the y-intercept. So we're going to use that approach now. And then we've got some of these ones here that all pass through the origin. So have some fun with those. Pause the presentation, have a go, and then check your answers one by one as you do them. So you just toggle on. Here they are here. There are your answers. So we just go to there. So you can toggle forward and back with this presentation and check your work as you go. Don't do too many and find they're all wrong. Check it as you go. All right, let's move on now and have a look. Lines parallel to the axes. Well, these are friendly creatures because, as we said before, if y equals a up here now, if y equals a, then the line is going to be horizontal. Because y doesn't change. Y equals a. A is a constant we're saying here. And this is going to be constant. And the slope or the gradient, as we said before, was 0. Not 6. Looks like a 6, mate. That's 0. And down here, if we have, we'll come up here first, if we have x equals a constant, there it is here. X equals -2. Then that is a vertical line, and the slope is undefined. undefined slope. Okay, do you remember that? And so these are fairly easy ones to draw the graphs for. Okay, so let's go on and have a bit more practice of a mixed bag of problems, and I'll leave you to use your knowledge now to try and do these. So here we are, here's some here, 5 and 6. So a bit of multiple choice stuff here. Pearson's like that. I don't like it particularly, but have a go. And 5 and 6, pause the presentation, the solutions are coming up in a minute. And then 7 and 8, lots of graphs here of those horizontal and vertical lines, easy ones there. Okay, and let's have a look at the solutions now. Okay, I think we can get them all on. No, not quite. Just you can pause it as you go there. Oh yeah, we might be able to. Can we get them all on there? Yeah, sort of. Okay. All right, check your work as you go. All right, now with Pearson's, of course, we have extended problems, reasoning and understanding, and then open-ended. So let's come on down and have a look at those. There's the rest of 7, missed that, and 8 there. Okay, keep coming now, and now we have the understanding problems. 9 and 10. So pause it and have a go, and then we come down to the solutions for 9 and 10. Just check those off, toggle backwards and forwards, check your answers. And let's have a look at the 11, there's a few here. Good to go on and challenge yourself, not just stop at the basics. So there's 11, and I think we come down to about 15 in a minute. 12 and 13 and part of 14. Pause it and have a go, and then 14 and 15. And let's have a look at the solutions to those now. Don't forget this hint here. Okay, let's go down and have a look at the solutions, a bit at a time. That's 11A through D. See how he went with that. And then we've got 12 through 14. And 15. Okay, so that's that bundle, and now what we've got are some open-ended questions. So the solutions to these vary depending on what examples you use to try and answer the question. So have a look at these, and we'll just go down, I think, down to 18. There's 18. And let's have a look at the answers to those now. And of course, you can choose different answers here because it's open-ended. It doesn't say it's a particular line. There could be a whole family. You might pick a different one. So have a look, mark your work. I hope you're getting excited about the skills you're building up. Remember, what's the answer to our central question? What makes a line straight? Hey, it's the constant slope or gradient. Okay, constant slope ensures that the points don't wander. You've got to keep that y step on x step constant, mate. Okay, look forward to seeing you in the next presentation. For now, it's cheers from me.